excuse me, great way to start. You'll recall, or at least tell me that you'll recall, whether you do or not, humor me, that an ANOVA, analysis of variance, and we've reviewed this recently, an analysis of variance is used to test if there is a significant difference between usually 3 or more groups. It can be used for 2 groups, but usually we run an independent t-test on that. So it can be used for 2 or more groups. So is there a significant difference between the test scores of Class A, Class B, and Class C? And you have to have individual scores for Class A, individual scores for Class B, and individual scores for Class C. That's a pretty stereotypical analysis of variance, or ANOVA. So I've got, let's say, 3 different teaching methods, A, B, and C. Those are my 3 classes. So I want to compare the scores. My next what if is, well, what if I want to add a little twist to that? Yes, I want to compare the scores, but also while I'm comparing those scores, I wonder if it matters differently to boys and girls. So I'm throwing in an additional variable. Now in this case, it's an additional independent variable. Yes, it's a two-way ANOVA is always an additional independent variable. But because you asked it might be dependent, maybe we'll deal with that in another procedure. Sneak preview of coming attraction. If you have more than one dependent variable, that's multivariate ANOVA or MANOVA. But a two-way ANOVA is when you have an additional independent variable. So let's look at an example and call up lesson 26, data file 1. And that scenario is given to us at the bottom 4th or so of page 192, the first page of lesson 26, the bottom of 192. Okay, so what we are doing, and again, I'm just going to kind of talk through this paragraph with you. I won't overly insult your intelligence by actually reading it all to you. But what we're going to do, we are interested in different methods of note-taking strategy. I've got a method 1 and a method 2. 2 different methods, 2 different approaches to that. I want to see how this, if there's any difference between the 2. But I also wonder if it's different for men and women. So my type of note-taking strategy is one independent variable. The other independent variable is gender. So I now have 2 independent variables. So what I've got, and you can read this, they've got a certain number of people in method 1 and method 2, and then I've also got a control condition, where it's not one method or the other, just kind of general. So I've got 3 different groups, hence the ANOVA. So that's one variable, but the other group is gender. So this is called a 3x2 ANOVA. If you look at the next to the last line on that page, and I will insult your intelligence and read this to you. The design for this study may be described as a 3x2 ANOVA, the number of levels of note-taking by the number of levels of gender. 3 groups of note-takers, 2 genders, 3x2. I'm not overly concerned that you get which is which. It doesn't really matter. It's just it's a two-way ANOVA because we've got more than one independent variable. That's the whole key right there. So here's my data, and my dependent variable is the improvement in GPA. So person number 1 improved a quarter of a point, 0.25 improvement. Person number 2 went up a whole point. So those are my GPA improvements. That's my dependent variable. Those are my dependent variable numbers. So if we go to run an ANOVA and we start this, there's very little we do different than we ran in just a one-way ANOVA. For a two-way ANOVA, we still got to analyze. We go to general linear model, even though there's an ANOVA option elsewhere. Some of you have seen that probably. But general linear model, and you'll see an example in another procedure why we go here and not the regular ANOVA one. This is still univariate because it's got one dependent variable. And if I look at my boxes, sure enough, there's room for one dependent variable, but notice the box for the fixed factor, which is another name in this case for independent variable. Again, I don't know why they use different names like this, but they do. Could be grouping variables, you know, some procedures do that. But that's the independent variable. So there's room for only one dependent variable. That's the change in GPA. But the other two are independent variables, so I'm going to put both of them here. And it really doesn't matter which one you put in first. Fixed factor and independent variables are synonymous, yes. A couple of things I'm going to look at. I'm going to look at options, and I want all three of these things. I know now gender makes sense. I want gender over there. I want method over there. But look at this gender times method or gender by method. That has to do, and this is what's different in a two-way ANOVA, that has to do with the possible interaction. Meaning the different method may be different for different genders. How the two independent variables work together. We're going to test for interaction of variables. Also, vocabulary-wise, the gender and method, those are called main effects. So we've got main effects and we've got interaction. So don't forget to move the interaction over, otherwise you're not doing a real two-way ANOVA. So I'm going to move interaction over there. I'm also going to click, I want descriptive statistics, I want effect size, and I'm going to click homogeneity test, which will not come into play much here, but it will in another procedure. And I'm going to click continue. Too fast. Homogeneity. Sneak preview of coming attractions or something called. We're going to talk about the homogeneity of slopes assumption later. Oh boy. Calm down. Okay, yeah. Everybody's telling me I'm going too fast. I'll pause. Let me say it again. Let's go do it again. Okay, if I go to Analyze, General Linear Model, Univariate, so nothing different at all so far than a plain old ANOVA. Oh, it didn't leave everything there because it didn't do any analysis. Okay, the change in GPA is a dependent variable, same as a regular ANOVA, but there's more than one fixed factor. That's the difference. Two-way because there's more than one of these. So again, we have more than one independent variable. Possible causes for the outcome. The outcome is the dependent variable. The input is the independent variable. Yeah, pretty much everything we've done, we've identified independent and dependent variables. So yeah, in that case, it's the same thing as all the other stuff is, yeah. So, digested up to this point, okay? For options, again, we want it sorted by gender. We want it sorted by method, nothing new there, except we move both have two things over instead of one. And we also want gender times method because of the three options. This is looking only at gender. This is looking only at methods. This is looking at them together. So the gender times methods, that's the test for interaction, meaning that gender and method may work together differently for different parts of different groups. Some method may work differently for males than it does for females, or males may benefit more or less from a particular method than females do. So all this, putting it together. So one of our tests, the first thing we're going to look at, one of the first things we're going to look at, we've already looked at a few things, is the interaction. Is there a significant interaction? So I'm going to continue, and I'm ready for an output window. He said he's ready for an output window. There it is. Okay. Look at these three lines in the tests of between subject effects. Now, you got a bunch of tables, as you always have. The first one's just going to tell you, how many men, how many women, how many in each group you have. Just the ends. But the test of between subject effects, look at these three lines right here. Gender, the three things we selected a second ago. Gender, method, and the interaction of those two. So I'm going to look here, here, and here. The question was, we moved over three things here. If there's more than three things to move over, we're going to look at all those here. The answer is yes, but it gets real messy if you have more than a couple things to move over. Because as it is here, we've got women in group 1, men in group 1, women in group 2, men in group 2, women in group 3, men in group... That's like 6 different... That's the 3 by 2. 6 different categories when you slice the pie all the ways we're talking about. So if I threw in a third one with a bunch of levels, it's going to grow, yeah, that's exactly the word I was looking for, yeah, a lot. Okay, so the 3 lines we're looking at, first of all, look at the interaction line first. That's the last of the 3 in this case. So the last of 3. Okay, we got lucky. Well, it was a planned luck. But the interaction is not significant. Whew, that saves us a lot of work, actually. Unfortunately, in the next example, we're going to see how much work that saves us here. So we don't have to look at interaction. All we have to look at is gender and method. I can look at both of them separately. I don't have to look at them together because the interaction is not significant. So I have, so there's no significance of the interaction. There is significance for both of the main effects, though. So both the gender and the method have p-values of less than 0.05. So gender is significant. There is a significant difference between men and women. And method is significant. Somewhere between groups method 1, 2, and 3, there's some pair that's significant somewhere, maybe more than one, at least one, though. So if you get significance in an ANOVA, what do you have to do? You have to do a post hoc follow-up analysis. Now, which follow-up do we need to do? Do we need to do follow-up for gender? If significant, you fell into my trap. No, we don't need to do follow-up for gender because there's only 2 of them. If gender is significant, the only possibles you can have is between men and women. So I don't have to follow up for gender. When you just have 2 categories or 2 groups, gee, I wonder which pair there's a significant difference. Well, the only pair you have. So we don't have to do follow-up for gender. We know that. Now, I haven't looked at the means yet. I'm not sure which way they're, whether men are higher than women, or women are higher than men, but whatever the means are, that tells us which way it is. I just know there's a difference between men and women. However, for method, I do have to follow it because there are 3 groups. If you ran an ANOVA for a situation where you could run an independent t-test, you don't have to do any follow-up because there's only 2 groups. In this case, gender, there are only 2 groups. But method, we got a follow-up method. I'm letting it digest. Say it louder. If it's worthwhile. Okay, probably in a much better, probably in a more articulate way. Okay, you don't have to do follow-up if there are only two things, two different kinds of things. In gender, there are only two different kinds of things. But in methods, there's more than two different kinds of things. So that's why we have to follow up methods. No, but, well, we don't have to worry about this one because it's not significant. This is significant, this is significant. But I don't have to follow up gender. There's only two. I have to follow up method because there's more than two. Wait time, wait time, wait time. Okay, you folks playing the home version of the game caught up okay? I'll take that as a vote of extreme confidence. Or scared confidence, I don't know. Alright, so here's how we follow up. And I'm following the steps on the top page 198 if you want to do that. Now I've already got everything in place, so when I go back to analyze and get rid of the ink layer, I go back to analyze, general linear model, univariate. I've got everything in the same place. Normally with an ANOVA, we set up the follow-up at the beginning. But this time we're not going to do that. We're going to only go back if we need to. Well, we need to. So I'm going to do post hoc. I don't need gender. I just need method. So I'm going to just move only method over there. Go back where? Oh. That is correct. Okay. So we don't follow up gender or male, female. Let me do that again. If I went to analyze and I went to general linear model and I went to univariate, that gets me to where I put everything in the right places. So I go where I don't go back, I just have to go there again, if that makes sense. So you don't have like a back button to hit, you just have to go the same track you took the first place. So post hoc, just for method, move method and only method. You can use gender over it, it won't like yell at you or anything. It'll just say, well, you idiot, you already know the answer to that one. Not really, but it'll tell you the same thing you already know. Again, it won't give you any new information. We're going to follow up with the to key. Now notice this is equal variance is assumed. That has to do with that homogeneity test. I'll just say that for right now. I'm going to continue, and when I click OK, I'm going to get some addition. I'm going to get to, well, I'm probably going to get the same thing I got in the output window again. I want to look at multiple comparisons. So this compares, and this is the same table we saw with an ANOVA all along. I want to compare method 1 with method 2. I want to compare method 1 with the control, and I want to compare method 2 with the control. Everything I didn't connect with my connect the dots game is duplicate information. So I'm looking at these three lines that I connected the method 1 and method 2 with. So I'm looking at the first line. How about is there significance between method 1 and method 2? And I'm right here. Yes, there is significance. That is a significant difference. How about between the method 1 and the control? No. How about between method 2 and control? Yes, because again it's less than 0.05. Now, okay, so 1, 2 and control. Yes, no, yes. The way I can say this, again, we had a little bit of trouble writing this up, I think most people do for an ANOVA, is there's a significant difference between method 2 and both of the other methods. That way you can talk about two differences just in one sentence. Method 2 is significantly different than both of the other two. You can say yes, difference between 1 and 2, yes, difference between 2 and control, but to kind of combine those, there's a difference between method 2 and each of the other two. And that's the result. You know there's a difference between men and women, and you know there's a difference between method 2 and the other two. So by doing a two-way ANOVA, we had two, again, as the word is, two main effects. Method and gender. Significance both ways. So you don't have to punch too many more buttons to get kind of twice the output that you might be looking for. No, between method 2 and the other two methods. Method itself, method is a main effect, not just one particular kind. Overall, the variable of method is a main effect. The variable of gender is a main effect. The combination of method and gender is the interaction. Okay, you get really lucky in a two-way ANOVA if there's not significance in the interaction. But sometimes there is. And just for fun, let's see. Yeah, that too. I heard you. Okay, let's get rid of this stuff. Okay. And let's open Lesson 26 Data File 2. It's the same scenario. They've changed some numbers to where it comes out a little differently. Same questions, same variables, different values for the variables. Some numbers are different. So we'll see how that affects the results. All right, we do the same thing. In setting up, we're going to go to Analyze. We're going to General Linear Model. We're going to Univariate. Our dependent variable is change in GPA. Our fixed factors are the other two. We're going to go to Options. And I want to look at just the gender. I want to look at just the method. And then I want to look at them together. Just one, just the other, and then together. Nothing new, at least not in the last 15 minutes. I want to make some selections. I want to select descriptive statistics because I want the means and standard deviations. I want to know the effect size. I want to, just for fun, select homogeneity tests. Are we all equally unhappy? Okay. Continue, because that's my job, you know. Continue. And I'm not going to click on post hoc yet because I don't want a bunch of junk if I don't need. I got enough of junk that I don't need. Why would I want more that I don't need? I'm going to click OK, and I'm going to get an output window. So if I scroll down and I look at these 3 lines, gender, method, and interaction of gender and method. If I look at my significant column, did I not click effect size earlier? I don't remember that column being there, but I want it there. Is there a significant difference in gender? No. Is there a significant difference somewhere between the different methods? Yes. How about the interaction of gender and methods? Rats, yes. So we've got to deal with interaction. Again, interaction means that some method affects some portion of some gender differently. And again, this is a 3x2, so there are 6 possible ways you can have things. Very carefully turn over to page 200 in your green Salcon book and let that sink in for a second and scare you half to death, because you see what looks like a bunch of program coding. Well, it sort of is. If you have a significant interaction, here's what you got to do. You got to get rid of all this ink first. We're going to go back again, to go back to where we were. We're back again, as I say. General linear model, univariate, and everything will be in the same place. It's the same place you went back to do the post hoc stuff. And we still need to do follow-up for just gender, but we also need to do it for interaction. Take a deep breath, click paste. You got back to, okay. Yeah, don't go, yeah, we're not doing that. That's, yeah, okay. We don't, well, you can post hoc for methods if you want to. I was just kind of waiting to do that later because we already know how to do that. Watch this. Go to paste. And there you see you got all that messy programming language kind of look stuff. That brings us to what step 4 is on page 200. Copy one of the lines. Copy this where it talks about the interaction. See what I've highlighted? We're following up with interaction. That's the one line that talks about interaction. I'm going to copy that. And then I'm going to paste it right afterwards. So I've got it there twice. I use Control-C. You can use the editing stuff at the top. You can right-click and say paste, or I just use Control-C because that's how I paste. Okay, the reason we want that line in there twice is because we've got 2 variables. So it actually kind of makes sense. Now, look what it says in step 5. For those 2 lines, we've got to add something to each of the 2 lines. For the first, and we got to add, and the reason again we have 2 lines because there are 2 independent variables. So for the first line, we're going to say compare, and I don't know if it matters if it's all caps or not. I'm scared not to. I just know it works this way. Compare parentheses, gender, close parentheses, ADJ, parentheses, LSD. Again, that stands for least squares, not what you're thinking of. And we do the same thing for the second line, except instead of saying gender, we're going to say method, because that's the other variable. I don't know. No, that one I did know. The LSD stands for least squares difference. Okay, so we've duplicated the interaction line. We've added some stuff to the end of each one. We added stuff to one line for one variable, gender. We added stuff to the other line for the other variable, method. And actually, they actually have some kind of plain English stuff here. After that step 5, they say it's the kind of the same thing I said, but the way they say it's more scholarly. The first statement instructs SPSS to compare men and women for each method. The second statement instructs it to compare the methods for each gender. So the first way, you've got it headed by one way. Gender, method 1, method 2, method 3. The second way, you've got it headed by gender and, by method 1, method 2, method 3, and then each one men, women, men, women, men, and women. I'm thinking it wouldn't do anything. Yeah, spell some of the words correctly. Yeah, just pick a couple, you know. It just wasn't one I picked. All right. So, again, it sorts it. It gives different priorities in sorting. You ready? Okay, the next thing we do, step 6, highlight the syntax. I don't know why it just doesn't know to do that, but it does apparently. Yep, the whole space. I don't know. I don't see that line in mine. We'll see. If it blows up, let me know. Highlight it all. Let's see what happens. And we click Run, which is one of our top menus. I think you want it all because when you highlight Run, you're going to have to run the selection, and you selected everything. So I'm guessing it wants. If you have that extra line, I'm guessing it wants that. And when I click this, are we ready? Let me wait a second. I'll wait, let the drama build up because it's so exciting. Somebody mentioned an old Commodore 64. I can do better. Now, I had a Commodore VIC-20. It's even worse. And I had a tape drive. I mean, I'm sorry, I can talk about punch cards and stuff too, but I'm already old. All right, selection. And I get some output stuff. Okay, note what I get. I get it sorted for men and women for each method within those. Now, again, this is just descriptive stuff. Let's go down to, how far do I want to go down? There's where I want to go down. Oops, where's my... Did it give you something funny at the bottom? What did it say? Warning, danger? Did somebody else spell something wrong too? Okay. All right. There are two, of all the tables that popped out, there are two that are headed pairwise comparison. Here's the first one. Of method 1, method 2, and method 3, each one of those compares men and women separately. So for method 1, is there a difference between men and women? Now again, there's duplicate information here because these two lines for method 1 are the exact same thing. They just change the order and subtract differently. Men and women, men minus women, had a difference of 1.165. The key thing here is the significance. All right, if I can get it to right. For method 1, there is a significant difference between men and women. Now the line under that I don't need. It's the same thing. Notice it's the same significance and it's the same actual numbers, except there's a negative on the difference. So I don't really want to look. I want to look at this line, and this line. Oops, come on, Don. Just the top lines for each of the three methods, method 1, method 2, and the control. So there's a difference between men and women in method 1. There's a significant difference between men and women in method 2. There's not a significant difference between men and women for method 3. So that's where everything is grouped by methods. Now, next we'll look at where everything is grouped by gender. Or at least gender. But this is method first, then gender. The other is gender first, then method. So there's a significant difference between men and women for both method 1 and method 2. Am I ready to scroll? Said or no? Okay. I'm going to scroll, by golly. Scrolling. I'm going to scroll down and look at my other pairwise comparison. There it is. Notice I've got two parts, one part for men, one part for women. The other I had three parts for method 1, method 2, and control. Now I've got two parts, one for men and women. For men, I want to compare method 1 and method 2. Method 1 and control. And method 2 and control. Again, the lines I've not connected are duplicate information. The difference between method 1 and control is the same as the difference between control and method 1. For women, I want to compare method 1 and 2, method 1 and control, and method 2 and control. So for men, is there a difference between method 1 and method 2? And again, this is not different information. Well, it's not. Well, it's separate information. Is there a significant difference between method 1 and method 2 for men? No, because again, it's not less than 0.05. Is there a significant difference for men for method 1 and control? And the answer is yes. Is there a significant difference for men between method 2 and control? And the answer is not quite, or no. So for men, there's a significant difference between method 1 and the control group. That's the only one. What about for women? Is there a significant difference between method 1 and method 2? Yes. Is there a significant difference between method 1 and control for women? No. Is there a significant difference for women between method 2 and control? Yes. So for women, there's a significant difference between method 2 and the other two methods. for women, not for men, for women. That's what interaction does. It separates them out more specifically. Because it's not just is there a significant difference between this and that. There may be significance for men that's not significant for women, and we see that here, or vice versa. The second one, okay, method 1 and method 2 different. Method 2 and control different. Between method 2 and the other 2 groups. Well, yeah, I've got 2 check marks, here, here, and here, and what those check marks have in common is method 2. Yeah. With men, I just have 1 check mark. It's just between method 1 and control. That's all I can say about that. Pausing for a second. Okay, let's say just a little bit about how these things translate to APA write-ups, because you get to do one. Yeah. So APA write-up for a two-way ANOVA. Well, the difference is there, first of all, is there a significant difference in terms of interaction, yes or no? Well, the first example is no. Well, that example is written up on page 205, and I didn't write a separate one of these for you because it's a little more obvious where the numbers come from with the output windows here than it was for the multiple regression. Okay, a 3x2 ANOVA was conducted to evaluate the effect, again, describing what it is. Means and standard deviation are presented in table 2, or table 21. I wish I hadn't erased that output window, but that's okay. I've got the more complicated one here. I give my regular sentence of f of 2 and 54 degrees of freedom respectively with the f value and the p value. I'm having trouble saying this without looking at it. Let me go back and look at it again. Okay, now I can line it up. Okay, all right. Okay, middle of page 205. The ANOVA indicated no significant interaction between note taking and agenda. Again, the significance line is right here. So I'm going to get 2 and 54 f 2 and 54 degrees of freedom. That f value is equal to 2.92. The p value is equal to 0.062. See where that comes from? Okay. I know, which is another thing that makes it more difficult to teach you this way. 0.062, right here. And that's the same sentence that's right in the middle of the paragraph of the write-up on page 205. I am not showing. Is this showing up at home? My monitor's not showing this is showing up. Are you seeing this on your screen at home? I'm not sure I'm getting this recorded, but I'm also frozen. Okay. It's probably my monitor then. Okay, there's no significant interaction. Again, we got three different kinds of F-tests. There's for the gender, there's for the method, two main effects, and then the interaction. We have to report, we're going to report all those. The first thing we report is the interaction. Also note it gives you the partial eta squared of 0.10, which is this number. That's awful. Yes, always do the interaction first, because that tells you if you've got another step after this or not. It tells you if you got to do that syntax copy and paste stuff, and we don't like to do that. It doesn't matter what you choose next. So there's no significance for the interaction. That's the first sentence I wrote here. It's the sentence I pointed out in your text. And then, but there is significant main effects for note taking. If they did note taking next, it doesn't. You don't have to though. Yes, because that's effect size. So the significant main effects for note are F again of this two, the one by method, and the same 54. So this 2 goes this 54, and there's my F value, and there's my significant level, and there's my eta squared. And the next is going to be 154 because gender only has 2 categories. Method had 3, gender had 2, so there's going to be 1 degree of freedom. So that's going to be, and I'm just going to write over stuff, F of 1 in 54 equals 15.86. T is less than 0.001. Eta squared is 0.23. Again, it does. I know I'm writing messy, but it's fairly legible in your text. If you'll look over on the next page of the text, there's one more paragraph which deals with our follow-up analysis we had to do. And again, we didn't have to do follow-up for gender. Matter of fact, they said at the end of that one paragraph before the chart there where it gives you all the standard means and standard deviations, they just say the gender main effect indicated men tend to have greater improvements than women. I don't know why they added it's not the focus of the study because I thought it was, or one of them. But then they say in the next paragraph, top of the page, we're having to follow it for the main effect of method, and we pick the Tukey procedure, and we find from there that going through all this type 1 stuff, results indicated that the group using the second note-taking method improved GPA slightly more than either the first method or the control group. See how they use the same wording I suggested? Method 2 was higher than both the control or the first method. And kind of their plain English summary at the end. Overall, this analysis indicates the, I don't like they say this kind of uppity, the superiority for the second note-taking method. I would say something like the second note-taking method, results indicate the second note-taking method was associated with higher levels, higher improvements of GPA than the other two. I would say a little, I don't know, it seems kind of snotty the way they say it here, superior. Still can't hear? Oh, got a sound problem. Sound working? Testing, 1, 2, 3 for sound? Nope. Okay. Apparently not. Is sound working now? Yeah, I think it is. Sorry about that. Okay. Do I need to repeat something? I'm not sure when that went out. I was just finishing going over the AP write-up when there's not a significant main effect. So my next question is going to be, and that's the easy one. So the next one is, what if there is a significant main effect? Let's close this one out and look back at the output for L2. Okay. Staying on page 206. Again, I'm just going to kind of go through real quickly and kind of circle where the numbers come from. And I'm going to have to scroll, so I can't show them all at once, unfortunately. Okay, 3x2 ANOVA, we're trying to do the same thing. The results for this indicate a significant main effect because of these 3 lines. That's significant. Again, it's the it's the same one. It's just, the difference here in the first write-up is there is a significant main effect. So, indicate a significant main effect, and F of 2 and 54 comes from right here. That F value is 17.81. Well, no, it's not. Oh, I'm looking ahead now. Oh, they do this backwards. They don't do the interaction first. They do that one, the last one. The last part of the paragraph, a significant interaction between note-taking and gender, F of 2 and 54 equals 10.54. I would do this first. And then the p-value is less than 0.001. Yeah, look at the very end of that paragraph under significant interaction on page 206. You don't have to. It's just that I think it's good practice too, because that tells you how much work you're in for or not in for pretty soon. So I like to look at that first. Anyway, just to kind of sum that up, they have these F values, including degrees of freedom, for all 3 lines. The interaction, and the main effect of gender, and the main effect of method. And then paragraph 2, they go on to say, because the interaction is significant, they look down here at the pairwise comparisons. That's where we did all that syntax stuff. I'm not going to have you do a lot of that. I'm going to give you some choice in this stuff. And sometimes you can kind of eyeball things without getting the exact numbers out of it. So I would suggest to you, write up one that's not significant in the interaction. But if it is, at least you've seen what to do. Now, let me tell you a couple things, and then the examples take a long time, so I didn't get through a lot of them. Your homework is going to be in With 1810. Oh, and I need to help you set that up before I leave. I will tell you that if you want to write up one of the other 2 exercises in lesson 26, exercise 1 has a significant interaction. Exercise 2 does not. Lesson 26. The 2 exercises at the end. Exercise 2 does not have a significant interaction. So you can do, and you can do the homework problem too. Let's look at that now. I know we're running kind of long, but let's go to let's look at this homework problem just for a second to make sure we all get it set up right. So let me at least get you started on that. Yeah, 1810 on page, again, the Whit book, page 419. This is your only homework problem. Don't get too excited; it's messy. Although I don't remember if there's significant interaction or not. Okay. We've got we've seen this vitamin C example before, but we've added sauna exposure to it. So I've got variables. I've got the number of days, and I've got vitamin C, and I've got sauna exposure. So putting those in no particular order. Yeah, sauna, vitamin C, and the number of days of discomfort due to colds. And again, a higher number means more discomfort. So those are my 3 variables. Do you remember how we set up, or do you remember that we did set up SPSS to run a 2-way chi-square? It's a lot like that. Actually, it's pretty much exactly like that. We did for the 2-way, not for the 1-way. Okay. Let's just enter a number of days here. So I'm just going to go down 6, 4, and 5, and 5, 4, 5. Oops, 5 I said. And then 4, 3, 4. And then 5, 3, 3. And then 4, 3, 2. 4, 2, 3. 4, 2, 3. 3, 2, 3, 3, 2, 2, 2, 3, 2, 2, 1, 2, 1, 2, 1. Okay, so I've got 36 people here, or 36 in the body of the table. See where it says the first 3 numbers come from no vitamin C and no sauna exposure. That's my 6, 4, 5. I just went straight down because they're all measures of days of discomfort. They're all the same variable. They're just in different categories. Yeah, so for example, this first 6 person, he had 0 sauna exposure, 0 vitamin C. So did the next person and the next person. That 5, 4, 5 in the middle of the left column had 0 vitamin C, but 0.5 sauna exposure. So did the next two people. And the last set in the first column, the 434, they had 0 vitamin C, but 1 hour sauna exposure. So that takes care of everybody in the first column. What about case number 10, that 5? Okay, okay. Do I have sauna and vitamin D switch? Vitamin C. Let's see. No, I think I've got it right. No, hang on. I do. You're right. You're right. I have them backwards. You're right. I have them backwards. I normally do it this way. These are all 0 vitamin C. I normally put all those in first. You're right. Thank you. And then 0.5. Yeah, because I never mess up anything, as we all know. Okay, so yeah, sauna is first. Duh. Now am I right? Now are some things right? Okay. Okay, the next 9 have 500 of vitamin C's. Is that 9? Yes. And the first 3 of those had no sauna, no sauna, no sauna, 0.5, 0.5, 0.5, and then 1, and 1, and 1. It doesn't matter what order you put these in, as long as you say they're in the right place. And then the next 9 had 1,000 vitamin C. Yep. And again, the groups don't have to be the same size. It's just kind of nice if they are. You can. And the last 9 had 1,500 vitamin C. Got an extra one here. Okay. If you're doing this now in real time, I would suggest you save this and not have to do it again. Yeah. So when you actually, I'm not going to do the analysis. That's the homework, to do the analysis. I'm not going to save because I'm going to reconstruct this so you can see me doing everything from scratch. Don't copy what I've got. You just get it from the book and put them in the right place. Yeah, and you might have put all the 0 sauna in people first. It doesn't matter. as long as you've got the number of days matched up with how much sauna they had and how much vitamin C they had. Yes, you're correct. Homework is 1810. That's where we are. And getting this set up is the last thing I intend to do right now, at least academically. This is a Way ANOVA. I would save it so you don't have to do all this, enter it again, yeah. I know, why would you don't want to repeat it? Yeah, really. Like, I'm going to close mine without saving it because I'm going to put all this stuff again when I go over this as a homework problem. So mine's gone. Yeah. The homework says doing an ANOVA and then the HSD test. That's all. That's the stuff that we've done and what you report in terms of your F values and all that. And the HSD is. Again, I'm trying to remember if there is if there is a significant interaction. You don't have to go through and do all that syntax stuff, but at least kind of eyeball it and see what you think it would be. And maybe I'll go do I'll go through all the syntax stuff when I do it next time. Run the Way ANOVA. Well, that's like the table. That's the table from like we went over with it for the write-up, yeah. That's eta squared. That's the effect size. Sub P for, I don't know. Estimate the effect size. Report the effect size. And again, in your homework, keep in mind two things that are really, really important. One is put your name on your homework because I get in a bad mood and grouchy and give bad grades when I don't see names. And if one of you doesn't put your name on it, I'll probably grade down the next person. So and answer the question. Don't just give me the SPSS output. Tell me what it means. That's interpreting the results. Yeah. What does it mean? Yeah. No, you don't have, you can do the write-up on this if you want. You can type it on your output window, yes, and which is nice and neat, and I can actually read it because it looks a whole lot better than what I write. But you somewhere make sure you tell me what the answers are. just run the ANOVA, tell me what it means. Bottom line, now the effect size is part of what it means, of course. How many APA write-ups are now due? This is the point where this is the second APA write-up. Whatever the syllabus is. And notice that notice that the syllabus is up to date. Okay. Thank you.